what seems to be, what is the #1 cause of death among people with HIV? The virus. Makes sense. But of late, an increase in cardiovascular diseases seem to be one of the reasons that's leading to death in these individuals. And one of the core features of cardiovascular diseases is the dysfunction of the endothelium. In this study, we see that the cardiovascular related illnesses seem to have increased twofold in these individuals. And 61% of the burden of HIV is still in the sub-Saharan Africa. When we talk about the dysfunction of the endothelium, we still look at the increase in the activation of the endothelium itself and the reduction in vascular compliance. These two lead to cardiovascular related illnesses such as stroke, increased blood pressure, among others. At the core of this seems to be the mechanism of increase in inducible nitric oxide synthesis, leading to an increase in amount of nitric oxide, as well as pro-inflammatory cytokines that seem to be on the increase as well. Increased levels of nitric oxide together with superoxide that are yielded from oxidative stress form peroxynitrite. Now, peroxynitrite seems to have this targeted effect on the endothelium, sometimes damaging the DNA itself, causing protein oxidation and nitration, and leading to the dysfunction of the endothelium, or indeed cell death. So this study in itself looks at these mechanisms, which are oxidative stress and vascular compliance, together with endothelial dysfunction, with the rationale that there is still increased levels of cardiovascular diseases and the limited data in sub-Saharan Africa. We want to see the vascular function, oxidative stress, and how these two relate, as well as endothelial activation. And to do this, we did a cross-sectional study in which we looked at people with HIV and those without. We looked at oxidative stress and how these correlate with endothelial dysfunction. Preliminary data and social demographic data were collected using NCD and WHO instruments, after which we took measurements of body fat mass, endothelial function measurements, including pulse wave velocity, arterial stiffness index, among others. In the laboratory, we did tests of endothelial activation using SICAM1 as a biomarker, as well as oxidative stress using nitrotyrosine as a biomarker. We did analysis using comparative tests, regression models, where we're very much interested in the relationship between oxidative stress and these endothelial function markers, such as carotid radial pulse wave velocity, carotid radial arterial stiffness index, whilst adjusting for other variables. We also pulled the data together to just see how holistically the data was relating among those with HIV and how it differed with those without HIV. Table 1 itself showed a few interesting markers. Not all of them have been shown here, but I'd like to draw your attention to the fact that carotid radial arterial stiffness, SICAM1, as well as nitrotyrosine, were markedly increased in people with HIV. We also noted in our models for carotid radial pulse wave velocity and carotid radial arterial stiffness index among people with HIV that BMI and SBP seemed to be very strongly associated with changes in carotid radial pulse wave velocity, as well as carotid radial arterial stiffness index, but not nitrotyrosine when adjusted for age. However, in HIV-infected individuals, only age was associated with changes. Only age was associated with changes in arterial stiffness. On the slide, we see that. We have on top a panel that is talking to carotid radial pulse wave velocity, and at the bottom, carotid radial arterial stiffness index. We also further subdivided them into male and female, with the left showing males and the right showing females. Though the two were very similar, we noticed that males had higher endothelial dysfunction measurements or carotid radial pulsar velocity, as well as carotid radial arterial stiffness index. However, let me draw your attention to how both the HIV negative and HIV positive were moving with increase in oxidative stress. If you look at your x-axis, we are at 1 over nitrotyrosine. So when I say increase, I'll be moving from my right to the left. So we see that in the initial phases, when there's an increase in nitrotyrosine, there would be also an increase in endothelial dysfunction in both HIV negative and HIV positive. But what we see when we go to the most extreme is that in the HIV negative, there's actually a reverse of relationship between oxidative stress and endothelial dysfunction. In the HIV positive, however, we see that increase in oxidative stress is directly proportional to increase in endothelial dysfunction. From these, we concluded the following, that endothelial function in people with HIV is higher, as is oxidative stress. We observed that the relationship between endothelial dysfunction and oxidative stress is nonlinear, and also that endothelial activation is higher in people with HIV. The limitations of our studies included the fact that we had an older HIV positive group and the lack of viral load management, as well as insufficient power to detect out influence. The fact that it was a cross-section study made us not see a causal issues, as well as the uncontrolled factors such as cholesterol, diabetes may have offered some limitations. However, we see this as preliminary data for further studies, including an evaluation of pulsar velocity, arterial stiffness index, and nitrotyrosine levels from the time of HIV diagnosis to elucidate how results may vary over time and also determine this causal relationship and mechanisms that could be going on. Also want to see whether this is generalizable to other parts or it's just a relationship or type of relationship that is seen in the sub-Saharan Africa. We have a couple of articles that have been released looking at arterial stiffness being associated with oxidative stress and endothelial activation among persons with HIV. We've also published on immune activation and arterial stiffness in lean adults and HIV on ART. These are my references. I would like to thank you so much. Thank you to Vanderbilt University, NIH, Lusaka Apex Medical University, as well as the University of Zambia. My name is Teresa Chikopela. Thank you.